'Cause I love you for infinity. Ah, ah. Okay. So that was the feeling I got when I solved this problem. So I was really happy. Yeah, this problem basically gave me an intent satisfaction, which I intend to like transfer to you as well, right? So yeah, let's go into the problem. So the case is we have two functions, which all are like functions of x, y, and z. Function g, which is also function of x, y, and z, and those functions are all zero, right? We need to prove that the dy by dx is equals to these partials, like there's difference in the quotient, right? Before we go into this problem, to get the feel of the problem, I will try to see what if, like in the case where the function is just of two variables, how do we find dy by dx, right? And the thing is, if there are two variables, we won't need the second equation. Like if there are three variables, we would need two different equations of f and g to solve for dy by dx, right? But if there's just two variables, we won't need that. We'll see later on why that is the case. Okay, now to find dy by dx in this case, what you can do is, first of all, try to see, like when there's a small change in x and a small change in y, how the f changes. So in this case, since f is always 0, the f will not change, right? So the change in f will be 0 when there's a small change in x and a small change in y. So a small change in x is basically the rate at which the f changes with respect to x times the amount of change in x. So this will give the change in f due to x, and this will give the change in f due to y. So basically this is the rate at which f changes due to y, right? And multiplying that by the amount of change in y, we get the change in f due to y. So basically this is change in f due to x, change in f due to y, and yeah, the entire thing, total change in x due to change in x and change in y, which is df, which in this case is 0. And this thing is also known as the multivariable chain rule, in case if you want to know like if this is a standard thing or not. Okay, now after we know this, to find dy by dx, what we can do is we have now got that partial f by partial x dx plus partial f by partial y dy is just 0, right? So if we divide both sides by dx, so this will just be 0. Over here dx by dx will be 1. Over here that will be dy by dx, right? So see, now we can easily find out dy by dx. Just take it to other side. So minus partial f by partial x, and then divide by that thing, partial f by partial y, which is just dy by dx. So you are getting the idea how to find dy by dx, right? And this idea is actually helpful in a lot of the cases. Like if this is actually an implicit function, so you can use this formula directly to find dy by dx. That's a helpful thing to do, right? So now that we have a feel how we find dy by dx when there is a single equation with two variables, let's see how we can do this question actually. Now over here we have f of xyz equals to 0. We have g of xyz is equals to 0, right? Now over here, if there's a small change in f due to small change in x, small change in y, small change in z, the change in f would still be 0, right? Because the f is always 0. So we see that the small change in f is 0, but the small change in f will be equals to the change in f due to x, change in f due to y, and wait, I wanted to move this. Okay, we find that's good. Okay, and change in f due to z, right? You get the idea, right? This is the rate of change, and then multiply the amount of change, that gives the change in f due to x, change in f due to y, change in f due to g. So this is total change in f when there's a small change in x, y, z. This is also called the multivariable chain rule. I have told you about that again and again so that you know actually what's going on. Now over here, if you want to find dy by dx, what you can again do is, divide all the sides, divide all of these terms, both sides, sorry. So divide all of them by dx, right? So then you get partial f by partial x plus partial f by partial y times dy by dx plus partial f by partial z times dz by dx, right? So get this equation, but notice that you cannot find dy by dx just from this equation itself, right? So let's try to get another equation. In how you should see this is, you can see it as, this is, let's say, a equation where these are the variables and these are constants. You can see it like, okay, first of all let me get another equation, then I will tell you like how you can see it to find dy by dx and dz by dx. Over here you can write this as, so again dz will just be 0 and dz will be given by change in z due to x plus change in z due to y plus change in z due to z, right? Now if you divide both sides by dx, this will just be partial z by partial x plus partial z by partial y times dy by dx plus partial z by partial z times dz by dx, right? Now we have these two equations. And we want to solve for dy by dx and dz by dx, right? If you want to solve for those two, how you can say it is, let's say these are our main variables and others are constants. Though they are not, just for solving. So we can see it as, let's say 0 is equals to 2 plus 3y plus 5z, and this is also 0 is equals to 1 plus 2y plus 5z, something like that, right? How would you solve for it? So you basically you will invoke the techniques of like simultaneous equations, like maybe you can invoke the Cramer's rule. Guys, I will use Cramer's rule in this case because that's the most simplest one. And if you don't know, first of all, I will actually summarize the Cramer's rule for you, and then I will go on solving this. Because if you don't know Cramer's rule, then it might be hard for you to understand, right? Okay, so now what the Cramer's rule says is, let's say if you have an equation, ax plus by is equals to c and dx plus ey is equals to f. From here, to find x, what you would just do is you would substitute c and f in place of the a and d, which are the coefficient of x, right? Basically substitute the coefficient of x. So this will be cf be, and denominator will always just be the same thing, that is a b d e, the main four coefficients. And to find y, to substitute the coefficients of y. This will be ad, then cf, and the denominator will always be the same, that's adbe. So this is how Cramer's rule works, right? And it's really simple, and it simplifies the solution a lot. So that's what we are going to do today as well over here. Now if you know this, again I think I need to shift this a bit because I need to make a space, right? Yeah, okay. Now, okay, so first of all let us write it in proper form. So over here from the first equation I will write it as a partial f by partial y times dy by dx plus partial f by partial dz times dz by dx is equals to minus partial f by partial x, right? Similarly over here, partial z by partial y times dy by dx plus partial z by partial z times dz by dx is equals to minus partial z by partial x, right? Now let's try to solve it. So if you want to solve for dy by dx, what we will do is, guys, and this is determinant, right? If you don't know, the determinant. Okay, now over here you must substitute this coefficients of dy by dx by these things, right? So we will have minus partial f by partial x minus partial z by partial x. So these are substituted. Now these other things, these things will be as it is. So partial f by partial z by partial z. I call this z, I don't know why, because I actually learned it from YouTube. Like some American guys say that, and I learned. And over here, this will just be partial f by partial y, partial z by partial y, partial f by partial z, partial z by partial z. Okay. Now if I do the determinant, I will get the answer now. So this that will basically be uh, let me okay, so this has negative sign, so I will write another one first. So partial f by partial z partial g by partial x minus partial f by partial x partial g by partial z divided by, this is partial f by partial y partial g by partial z minus partial f by partial z partial g by partial y. Oof, and that's the dy by dx. Let's try to see. Partial g partial x partial f partial z minus partial f partial x partial g partial z divided by partial f partial y partial g partial z minus partial f partial z partial g partial y. Yeah, that's right. So that's how we do it, right? Now guys, let me just give you one more generalization. Yeah, that what would you have done if there were, let's say, 4 variables and 3 functions, right? So let's say if you have f of x, y, z, w is equals to 0, g of x, y, z, w is equals to 0, and h of x and h of x, y, z, w is equals to 0. Again, you want to find out dy by dx. How would you do it? It's pretty simple and it's pretty same actually. So now over here also we know that this should actually be partial f by partial x times dx plus partial f by partial y times dy plus partial f by partial z times dz plus partial f by partial w times dw is equals to 0, right? So now if I divide everything by partial x, this would just be partial f by partial x plus partial f by partial y dy by dx plus partial f by partial z dz by dx plus partial f by partial w dw by dx is equals to 0, right? Similarly from other also we'll get the same thing. Like this will be, now let me take it to other side. Yeah, because that's what we are eventually going to do. We are going to take that to other side, right? So that will be minus partial f by partial x. Also let me do it for others. If I do it for z, I will get partial g, sorry, partial g by partial y times dy by dx plus partial g by partial z times dz by dx plus partial g by partial w times dw by dx is equals to minus partial g by partial x, right? Similarly, if I do it for h, this will be partial h by partial y times dy by dx plus partial h by partial z times dz by dx plus partial h by partial w times dw by dx is equals to minus partial g by, sorry, partial h, not g, minus partial h by partial x. Now if you want to find dy by dx, again use Cramer's rule. So this is where Cramer's rule is helpful, because in the previous thing you might solve it like even yourself by substitution or like elimination anyway, right? But for this one, substitution elimination will be too hard and Cramer's rule will be really easy. So that's how Cramer's rule is simpler. Now over here, dy by dx will just be the determinant of, so just substitute this first thing by these numbers, right? So minus partial f by partial x minus partial g by partial x minus partial s by partial x. Over here, that will be partial f by, other things will be as it is, these other coefficients will be as it is again, partial g by partial z partial h by partial z partial f by partial w partial g by partial w partial h by partial w divided by w. Now this is partial f by partial y partial g by partial y partial h by partial y. This is partial f by partial z partial g by partial z partial h by partial z partial f by partial w partial g by partial w partial h by partial w. So yeah, this is, oh, this is not dy by dx, this is dy by dx, I'm sorry, this is dy by dx. So this is the dy by dx in the case of 4 variables. So you also notice that for 2 variables one function was enough, for 3 variables 2 function was enough, and for 4 variables 3 function was enough. And this pattern does continue. We need we need one more variable than the number of functions to find dy by dx. So guys, this is how we do it for any general case. So I just didn't want to give you this particular solution, right? I wanted to give you information on everything that's possible, basically trying to help you know how to fish rather than giving you the fish itself, right? So yeah, now if you have this idea, you can do any problem, I guess. So yeah, so that's what's the benefit of coming to my channel, and yeah, I hope you guys would share it with your friends too. Hope you have a good day. Thanks for watching. Look forward to seeing you in the upcoming videos too.